Hello, Precalc. This is the video that you'll be watching on the 17th, which is Wednesday. So this will help you with Thursday's work, so please write it down carefully and please mentally engage with it. This is all topics you've seen before, so when you come to class, you should be able to do the problems that are just like these. So, do me proud. There's only one topic, Alex, that we have left that I haven't reviewed well, and we're going to take care of that now, and that is conic sections. So, the conic sections are the circle, the parabola, the ellipse, and the hyperbola. So let's review those. First one, let me see the time. Alright, so I'll cut this video at 7:06. Alright, let's go ahead and see what this is. First one. Alright, here we have an expression. I'm sorry there's a lot of glare in this video. I hope this is readable. I don't know what to do about it because I'm teaching in the classroom. Just hope it shows up better than it's looking like it will. I can try different colors as well. This conic section is a circle. And I can tell because the lead coefficient here would be x squared, this would be y squared. They're both positive and they have the same lead coefficient, 1. This one, you don't have to be 1, but it has to be the same. This is already in standard form, and I'm asking you to find the center and the radius and give me a sketch. So the center of the form that we are following, Hector and Kyle. Oh yeah, these are minus, both minus. This has all the secrets of the circle. So Hector, Kyle is the center, and the radius is r. So up here, we can use this information. It's always the opposite sign. So we're going to get a center of 2 minus 4, and the radius is 6, is the square root of this number, which is 4. Sketching it, 2 over, 4 down is the center, and we have a circle. Whoa, that's pretty bad. I used to be better at those circles. Alright. Alright, I'm going to erase that problem, so pause if you still need it. And let's have you go the other way. Alright, when I mean the other way, I'm going to give you the circle and you give me its equation. I'm going over 1 and up 2 to find the center, and I'm going to do that much better. Okay. Alright, so here we have this circle and I want its equation. So you have to know or bring on your card. So if you don't do a card, I can't help you with that. X minus, we have x minus h quantity squared plus y minus k quantity squared equals r squared. So let's fill in. X minus the opposite of the x coordinate. The x coordinate is 1, so we're going to put in the opposite of that in the formula. And the y coordinate goes here with its opposite sign. And the radius is 2, so we square it and get 4. This is the general form. This is the standard form for this equation. Speaking of general form, that's the last thing we have to do with circles. Again, pause it and go back if you still needed that. Here is a circle in standard form, general form. Let me write a little lower so I get out of the glare. x squared minus 4x plus 4, y squared plus 6y plus 9 equals 16 ninths. So the command is to graph this, and first you have to identify what it is. On the test, that'd be the first step. So you can see that the x squared term and the y squared term are both the same sign and the same coefficient, the unwritten one. So that's characteristic of the circle. You're going to do these for all of the ellipse, the parabola, hyperbola, circle as you gather your x, like you're out gathering eggs. Leave a space, gather your y's, leave a space, and move the constants to the other side. So 16 ninths, 16 ninths, you know, that's kind of icky to work with, isn't it? Let's before we gather our x and y, let's get rid of the fraction. I see that 9 in the denominator. If I multiply everything by it, it'll disappear. So that's better to work with. Alright, multiplying everything by 9, this appears on, this is your result. So now, after I do that, let me see if I'm following my own steps. Okay. Alright, was this the original? Yeah, I think this is fine. So now, let's put the x together, gather our x. Leave a space, gather your y's, and we have some constants that we can move over to the other side. So 16 minus 81 minus 36, and that is not what I got. I guess, what is 16? Oh yeah, that's right. So we have 16 minus 36 minus 81. So I'll get that number. You just see I moved the 36 and the 81 over, and it doesn't matter if it's negative for a while. At first it was bothering me, but now I see what's happening. In order to complete the square, and fill this in with a special number, you have to remove any coefficient in front of the x squared term. So we're going to factor it out. Then and then only can you complete the square. Alright, so let's see. 16 minus 36 is minus 20. Minus 20 and minus 81 is minus 101. Alright, so now I can go in and complete the square. Half of 4 is 2. 2 squared is 4, but that's really a 36, so I adjust for it by adding 36 over here. Then, is that showing up? Yes, I think it is. Yep, sorry. Then, half of 6 is 3. 3 squared is 9. 9 times 9 is 81. So when I add negative 101, 36, and 81, this all comes to 16, which is a good sign. It doesn't have to be a perfect square, but it usually is. Alright, now I will rewrite this as a perfect square. This is the square root of this sign, and the square root of that. If you square this, you will get this. So I went from a trinomial, 3 terms, to 2 terms squared. Alright, we will, to get in standard form, there's no number in front of this binomial squared, so I'm going to divide everything by 9. And let's see if I have more screen room. Not much. Alright, so I'm going to move this up top where the problem was originally written. And this will be the last step. So we're going to have x minus 2 quantity squared plus y plus 3 quantity squared equals 16/9. Alright, so that's the standard form that has all the secrets of the circle. So the center, Hector and Kyle, are sitting right there, and you have to use their opposite signs. So we're going to have 2 and, let me see, 2 and minus 3, just checking my work, it is correct. So the opposite sign of this, opposite sign of that, 2 minus 3 is the center, and the radius is the square root of that. 16 becomes a 4, 9 square rooted is a 3. So we can go to any coordinate plane, find the center, 2, -3, and draw a circle around that center of 4/3. Alright, so that's the circle. Alright, I'm going to shut down this part and show you the ellipse. Nope, maybe.